Typos may exist here since it was dictated from the PDF. From Exxon's 1982 memo introducing select employees to Exxon's climate change primer derived from late 1970s climate research. Detection of CO2 greenhouse effect. It is regarded by most scientists that a general consensus regarding the likelihood and implications of a CO2-induced greenhouse effect will not be reached until such time as significant temperature increase can be detected above the natural random temperature fluctuations and average global climate. These fluctuations are assumed to be half a degree Celsius. The earliest that such discrete signals will be able to be measured is one of the major uncertainties of the CO2 issue. A number of climatologists claim that they are currently measuring a temperature signal above climate noise due to a CO2-induced greenhouse effect, year 2000. In order to quantify the implications of detecting the greenhouse effect now, as opposed to the year 2000, estimates were made on temperature projections as a fluctuation of the CO2 concentration that existed prior to the Industrial Revolution. Available data on CO2 concentration prior to the Industrial Revolution tend to fall into two groups, 260 to 270 ppm or 290 to 300 bpm. In Table 6, possible temperature increases were estimated as a function of initial CO2 concentrations of 265 and 295 ppm. Temperatures were projected for three cases. This, 1. A temperature increase of 3 degrees occurs if current CO2 concentration doubles. 2. The greenhouse effect is detectable now, 1979, and 3. The greenhouse effect is detected in the year 2000. One can see in Table 6 that if a doubling of atmospheric CO2 will cause a 3 degrees Celsius rise in temperature, then we should have seen a temperature increase above climate noise if initial CO2 concentration was 265 ppm, or beyond the threshold of detecting such an effect now, if the initial concentration was 295 ppm. If we assume that we are on the threshold of detecting the greenhouse effect, then the average temperature due to a doubling of CO2 will be 1.9 degrees Celsius for initial CO2 concentration of 265, or 3.1 degrees Celsius for initial concentration of 209 ppm. Finally, if the greenhouse effect is detected in the year 2000, and the doubling temperature for initial CO2 concentrations of 265 and 295 ppm will be 1.3 and 1.7 degrees Celsius, respectively. Based on these estimates, one concludes that a doubling of current concentrations of CO2 will probably not cause an average global temperature rise much in excess of 3 degrees Celsius, or the effect should be detectable at the present time. Alternatively, if the greenhouse effect is not detected until 2000, then the temperature due to CO2 doubling will probably be under 2 degrees Celsius. Using the Exxon 21st century study as a base for fossil fuel growth patterns, the average global temperature increase due to CO2 would range between 0.8 and 1.6 degrees Celsius by 2030. A doubling of atmospheric CO2 would be extrapolated from the fossil fuel consumption rates of the 21st century study to occur at about the year 2090, with the temperature increases ranging from between 1.3 degrees and 3.1 degrees Celsius. The projected range presented above is considerably lower than the generally accepted range of 1.5 degrees to 4.5 degrees Celsius. Page 29, same document. The behavior of the main global temperature for making 50 to the present, contained within an envelope scaled to include the random temperature fluctuations, and projected into the future to include the 1.3 degrees to 3.1 degrees Celsius range of uncertainty noted above for the CO2 effect. Depending on the actual global energy demand and supply, it is possible that some of the concerns about CO2 growth due to fossil fuel combustion may be reduced to fossil fuel use is decreased due to high price, scarcity, and unavailability. The above discussion assumes an instantaneous climatic response results from an increase in atmospheric CO2 concentration. In actuality, the temperature effect would likely lag CO2 change by about 20 years because the oceans would tend to damp out temperature changes. Given the long-term nature of the potential problem and the uncertainties involved, it would appear that there is time for further study and monitoring before specific actions need to be taken. At the present time, that action would likely be curtailment of fossil fuel consumption, which would undoubtedly seriously impact the world's economies and societies. Key points needing better definition include the impact of fossil fuel combustion and the role of the oceans and the carbon cycle and the interactive effect of carbon dioxide and other trace atmospheric gases on climate.